So in this video, I'm going to show you the calculation differences in using a transmitted split point, a reflected split point, as well as using no split point at all. So based on the previous video where I showed you the red area here has to do with transmitted split point calculations, this gray with calculations with no split point, and the green with reflected split points. So keeping that in mind and moving down onto our graph here, we have a nice graph where it plots the laser signal in red in the transmittance mode, the laser signal in the reflectance mode here in green, which we can see as we about the first 30 seconds we have nice stable levels of lasers, which is used to calculate our laser average, and then we can see a dip in the signal of the transmittance and reflectance. And what that means is some of the organic carbon is being pyrolyzed to elemental carbon, so we're seeing a decrease in transmittance and reflectance. What the split point is once that laser signal gets back up to that level where it started at, that 30-second average, we consider everything before that point as organic carbon. So in this graph, we can see that at about 600, just before 600 seconds, everything before that is considered organic carbon. And then everything past that point is considered elemental carbon. So now if we scroll back up to our calculations using these split points, we'll notice that if we look at our split points with using the transmittance laser, we have a split point calculated of 594 seconds. And then if we look at our reflectance, we also have a split point of 594 seconds. So for this sample, we have good agreement between both reflectance and transmittance, and that they're exact same. And we can also double check that the carbon concentrations are both the same in the organic. Here they're 104.7, and then the same value with the reflectance. But if you'll notice in the middle here, when we calculate with no split point, we actually get quite a bit of a decrease in the carbon concentration, in the organic carbon concentration, sorry. And then we have an increase in the elemental carbon area. So that makes sense because without that split point calculation, we're seeing more of that organic carbon being classified as elemental carbon, even though technically it's not. So this is just something to be aware of when you're analyzing your samples with this Excel template, and that you should make sure that you know if you expect to see a split point calculation with your sample or not. And if you don't, then you can simply look here at this gray box where it says calculations with no split point, and then you can simply take the organic carbon concentration and the elemental carbon concentration, and then you have your total carbon concentration. So you can use those values for your sample and know how much organic, elemental, and total carbon you have in your sample. So that brings me to the end of this video, and in the next video I will show you how to change this template if you have different instrumental parameters that you want to run your sample on, because each template only works for those set with the instrumental